back to NCRT class 10th chapter number 12 electricity. Children, in the previous class we have learnt about practical applications of a heating effect under electric bulb and also fuse we have studied. So dear children, in today's class we are going to learn about electric power. The general meaning of a power is what, children? Rate of doing work. Isn't it, children? Rate of doing work is called as a power. So the consumption of a energy is also called as a electric power, or in other words, we can say that the rate at which the electric energy is dissipated or consumed in an electric circuit is called what? Electric power. In both ways we can define, children. Generally we can say that electric power is nothing but a rate of consumption of energy, or the rate at which the electrical energy is dissipated or consumed in an electric circuit. So how we can write in terms of a power, children? Power is equals to V into I. Means P is nothing but a V into I. Isn't it, children? And this can also be written as, this is what? One method of writing. And suppose this can also be written as V square by that is R. This is another way of writing, because we know that I into R. Isn't it, children? So P is equals to V into I means I into R into I. This can also be written as a I square into R. Means P is equal to I square into R. In these three ways also we can write the power values, children. You have to remember these three methods of writing power. And the unit of a power is watt, children. And it is often represented with capital W. Understand, children? The SI unit of a power is watt. And 1 watt is nothing but a, when in terms of this we need to define, children. Suppose if 1 amperes of a current is flowing at 1 voltage, means suppose if 1 ampere of a current is flowing, when it is operated through a potential difference of 1 volts, then it is said to be what? 1 watt. And generally this watt is a smaller unit, children. So we will go using larger units, like this is what? Watt is a small unit. Isn't it, children? So sometimes larger units we will use, like kilowatts. Children, kilo is nothing but 1000 watts, which is equals to 10 to the power of minus 3 watts, children. 1 kilowatt means how much? 10 to the power of minus 3 watts. And this electrical power in terms of energy, we can write it as a E is equals to P into T, children. Isn't it, children? The energy of consumption, the electrical energy consumption can also be written as the product of a power and time. Is the power unit is watt and time is hour. So the energy consumption is what? The electrical energy is watt hour. Is the unit for electrical energy. And sometimes we will write one larger units. Children, 1 kilowatt hour is nothing but a what is that watt value, children? 1 kilowatt means 1000 watts into hour means 3600 seconds. So 1 watt hour is nothing but a, when 1 kilowatts of energy is consumed in 3600 seconds, or 1 hour is said to be 1 kilowatt hour. Once again I'll repeat, children. 1 kilowatt hour is nothing but a, when 1000 watt of energy is supplied at 3600 seconds, then it is said to be 1 kilowatt hour, and this can be equal to 3.6 into 10 to the power of 6 watt second, or 1 kilowatt hour is equals to 3.6 into 10 to the power of 6 kilojoules, children. In terms of a kilowatt hour, how we will write? 3.6 into 10 to the power of 6 kilojoules, and this is called the commercial unit. Means commercial units or larger units, children, isn't it? Generally, to pay the electrical bills, we will use what? Units. At that time, 1 kilowatt hour is equals to how much joules of energy we are using? 3.6 into 10 to the power of 6 kilojoules of energy we are going to using, children. That's why, children, sometimes in order to pay the electrical bills, the units we are going to calculate. Means per unit we are going to multiply how much units we have consumed, and depending upon that we are going to pay the electric bill. Means the energy which we have used in order to occur the electrons to move in the electrical circuit, we are paying the bill, children. Sometimes we will think that due to what? Electrons, movement of an electrons, we are paying bill, but that is wrong statement, children. In general, whatever the energy which we have used in order to see the potential difference across the wire, means in order to see the charge across the wire, we are going to pay bill for that. Got it, children? In general, the commercial unit is called as a simply units, and the commercial unit is what? 1 kilowatt hour. Got it, children? 1 kilowatt hour is nothing but it is called as a commercial unit, and it is equals to 3.6 into 10 to the power of 6 kilojoules, and the simple unit of power is what? Watt. And the definition of it clearly says that the consumption of energy, how much energy we have used in order to see the electrons move in an electrical wire, and that is called as a electrical power, or simply electric power. It can also be defined in another way, that the rate at which electric energy is dissipated or consumed in an electric circuit, and by that we can write P is equals to V into I, and from Ohm's law V is nothing but I into R, isn't it, children? On substituting, we will get I square into R, and this can also be written as, that is, V square by R, and 1 watt is nothing but 1 ampere into 1 volt, and sometimes we will use a larger units like a kilowatts. Kilowatt is nothing but 10 to the power of minus 3 watts, children, and we will write the electrical energy as the product of a power and time, so we will write the unit as the watt hour, and 1 watt hour is nothing but what? That is 1000 watts. That is, in terms of a kilowatts, we will write it as a 1000 watts into 3600 seconds. Means 1 kilowatt hour is equals to when 1 watts of power is consumed when it is operated at 1 hour, and it is called what? 1 kilowatt hour, and generally this kilowatt hour is nothing but a commercial unit, which is equals to 3.6 into 10 to the power of 6 kilojoules, children. Okay, now we will study, or we will try to solve few numerical problems based upon electric power. Let us solve the first question based upon electric power. What will be the current drawn by an electric bulb of 40 watts when it is connected to a source of 220 volts? Means the voltage value they have given here and the power value 40 watts they have given. They asked us to calculate what is the current value here. So, what formula we have to use, children? P is equals to V into I. Isn't it, children? So, what are the given data, children? that is V is equals to 220 volts. Then power P is equals to 40 watts. I is equals to how much? Isn't it? Using formula P is equals to V into I. But we want what? I. So in terms of I, how can we write? P divided by V. Means this can be written as I is equals to, what is P value, children? 40 watts divided by 220 volts. Isn't it, children? Yes. Now divide this. 4 tens are 40. Then 4 fives are and 4 fives are. Then this 5 twos are 5 11s are. Isn't it, children? So 2 divided by 11 is nothing but a how much? 0.18. Isn't it, children? So how much amperes of a current we need, children? 0.18 amperes of a current is drawn here. In order to work that electric bulb, how much amperes of a current is using, children? 0.18 amperes of a current is used here. One more problem, that is an electric heater draws a current of 10 amperes from a 220 volts source. What is the cost of using the heater for 5 hours every day for 30 days? If the cost of 1 unit is 5 rupee 20 paisa, it means that first we have to calculate the power value using current and a V value. Isn't it, children? After obtaining the power value, we have to calculate energy consumption per day. Isn't it, children? We will get energy consumption per day. That we have to multiply for 1 month. Means 30 days we have to multiply. There we will get energy consumption for 30 days. And the cost of 1 unit is what? 5 rupee 20 paisa. We have to multiply that. We will get what? The energy consumption for 30 days. If the rating for per unit is what? 5 rupees 20 paisa. Okay, let us solve step by step, children. The given data are current I is equals to 10 amperes. Then V is equals to 220 volts. And power P is equals to, we need to calculate. Isn't it, children? Using formula P is equals to V into I. This implies what, children? P is equals to, what is the V value? 220 into I is 10, which is nothing but a 2200 watts. But what is the unit of a power, children? Kilowatts. So divide this by, what is this? P is equals to 2200 watts. Convert it to the kilowatts. Convert it to kilowatts. Then divide this 2200 divided by 1000, which means 2.2 kilowatts is the power consumed. Now, electrical energy consumed can be given by formula E is equals to P into T, children. Got it? Here we already know power value and the time value is what, children? That is 5 hours. Means directly they have given in terms of hours, and anyhow this is we have converted into kilowatts. So write that 2.2 kilowatts into 5 hours, which means how much, children? 0, then 11.0 kilowatt hour is the energy consumed per day. This is what the energy or electrical energy consumed for 1 day is how much? 11.0 kilowatt hour. So now multiply for 30 days. Energy for 30 days means E is equals to 11 into 30, which is equals to 330, means kilowatt hour, or simply you can say it as a units, isn't it children? Kilowatt hour is also commonly called, actually this kilowatt hour is what? Commercial unit. It is commonly called as a unit. So we can write E is equals to 330 units. And they have given 1 unit cost is how much children? 5 rupee 20 paisa. Suppose cost of 1 unit is 5 rupee 20 paisa. Cost of 330 units is equals to 5 rupees 20 paisa into 330, which is around 1716 rupees children, isn't it? 1716 rupees is the electricity unit, means we are going to get what? This much amount of bill children. Suppose if the cost of per unit is 5 rupee 20 paisa. Children, this is a very simple, don't get confusion. They asked as if the heater works for 5 hours every day for 30 days, means for month daily it is working what? 5 hours continuously, and such that the cost of 1 unit is 5 rupee 20 paisa. Calculate the cost of how much units you have used, that is for the 30 days how many units you have to use. First you have to calculate, and after obtaining that multiply it with the cost children. Definitely what? You will get cost of an electricity for the 30 days units you will get.